2.2, the rectangular coordinate system in the graphing lines. In this section, we are going to learn how to plot a point, how to graph the linear equations, how to graph the vertical and the horizontal lines, solve the application using the linear functions, find the distance between 2 points, and find the midpoint of a line segment. The rectangular coordinate system that consists of two perpendicular number lines, which is the y-axis and the x-axis. They intersect at a 90 degree, and these two lines create the 4 different quadrants on the plane. So when you have the quadrant 1, the order pair here, let me move the, okay. So the order pair here, all the point on quadrant 1 is a positive. When they come to the quadrant 2, you will have the negative x and a positive y. Quadrant 3, everything is a negative. On the quadrant 4, you'll have a positive x and a negative y. Origin, the midpoint here, this is the center. We call it origin. So at origin, everything has a 0, 0. So if I give you a pair point, 2, 3, since both of the numbers they are positive, then you should know this point is located on quadrant 1. If I give you a pair point has negative 2, positive 3, you should know this is on the quadrant 2. If I give a point is negative 4 and a negative 3, this would be the quadrant 3, and so on, so on. The graph of the equation y equals negative half x plus 4. If I give you this function or equation, how do you graph it? When you're at the high school, I know a lot of you use the rise over run, right? Rise over run to define the slope point and then combine with initial point that intersect with y, you can sketch the graph. Some of you go with a table. As long as you decide the x point, plug in the x point back to the equation, you will find the y value. And you can create a table with at least a 4 point or 5 point to sketch the graph. But here, I'm going to use the x-intercept and the y-intercept to sketch the graph. And we are going to use the same strategy for the rest of function in this course. So finding the x-intercept, we always did a y equals 0. Finding the y-intercept, we always did a x equals 0. So these two things, you need to memorize it. And always remind yourself, x-intercept, y equals 0, y-intercept, x equals 0. So now, getting the x-intercept, we did a y equals 0. So I'm going to set the y equals 0 equal negative half x plus 4. So negative half x equal negative 4, which is x equal 8. So the x-intercept, you will have the 8, 0. Finding the y-intercept, we let the x equal 0. So y is equal negative half multiply 0 plus 4. So when x equals 0, y equals 4. So your y-intercept at 0, 4. Now with these two pair of points, it's sufficient to sketch the graph. So I label 8, 0 is about right here. 0, 4 is about here. So combine these 2 points, I can sketch the linear equation by using these 2 points. Now, as here you can see, this is a negative slope. So From the equation, you have the slope number is -half. Y-intercept is 4. So this is a y-intercept. If you go with the table, you can pick any number you want, right? But normally we pick the small number, easier number. So if I go with table, I might just go with, this is x, this is y. I will pick the 0, I'll pick the 1, pick the -1, pick the 2, pick the -2. That's an easier way you manipulate with your, when you plug in those points into the equation, is easier way to let you find the y value. So you can do this way, determine your x point, plug in the x point into the equation and getting the y value. And from there, you can sketch the graph. When we say the graph of an equation is a line, we imply two things. Every point with coordinates that satisfy the equation will lie on the line. Of course, those points will stick with the line. Every point on the line will have coordinates that satisfy the equation. So they are kind of like back and forth. When the graph of